Hello again. Let's take a look at section 1.5, which covers factoring. In this particular problem, you'll see that there is a video which goes along with it. I'm going to show you the methods that I use the most often, but the videos may occasionally show you different methods. You are welcome to use whichever method makes the most sense to you. That's the one you'll probably remember the best. Let's take a look now at problem 1. We're looking for the greatest common factor among the terms in a polynomial expression. Now remember, polynomial means the variables have to be written in the numerator and they have to have whole number powers. They can't have decimal numbers for the powers or fractions. They also can't be negative, and that keeps them out of the denominator. So we're looking at negative 12x minus 20xy plus 8x cubed. We're looking for the greatest common factor, or GCF. When we think about it, greatest means the largest possible that will come out. Common means it has to be in every term. And factor means it has to be something multiplied or divided with other things. Now, when we're looking at common, we're looking at terms. What separates terms? Terms are separated by plus signs, minus signs, and equal signs. Since this is an expression, we don't have an equals, but we have a plus sign here separating the term 8x cubed. We have a minus sign here separating the term negative 20xy. Notice the negative goes with it. And we have a negative here separating the term negative 12x. So those are our three terms, and we want to see what's common. I usually go in order: numbers, then variables in alphabetical order. So let's look at the numbers. We have negative 12, negative 20, and 8. The greatest common factor that will come out of all three of those numbers would be a 4. So we're going to take the 4 out. Notice that the directions state that the greatest common factor must be positive. It's also possible to take out a negative 4, but then it would have a hard time checking which answer is correct. So they're telling you to make it be positive. So we'll pull out a positive 4 instead of a negative 4. When we take out 4, it's a form of division. Factoring is a form of division. So then we think about negative 12 divided by 4, which will leave a 3 behind. Now we do want to leave some space for other possible factors that will come out. So we'll leave some space there. Now we're going to have negative 12 divided by 4 to be a negative 3. Leave some space for other factors. Negative 20 divided by 4 is a negative 5. Leave space for extra factors. And 8 divided by 4 is a positive 2. Leave space for other factors. Notice that this stuff goes in parentheses. Now we look at the variables in order. The first one has an x variable. Does the second term? Yes, it does. Does the third term? Yes. The third term has 3 of them, but the first 2 terms only have 1. So the most we can take out is 1. That's the greatest that's common to all 3 terms. So we take out an x. Now we look at the next variable, which would be y. This center term here does have a y, but the first term and the last term do not, so it's not common. That means the y will stay in the center term inside parentheses. So the x came out, which leaves a 1 behind, so the first term becomes negative 3. Make sure that when you multiply these together, you get that first term back again. Now on the second term, the x came out, but the y stayed behind, so it's still there. On the third term, I took out 1 of the x's, but there are 3, which means if I take out 1, I've still got 2 left behind, and that's going to give me x squared. That means that if I write it in factored form, I have 4x times the quantity, negative 3 minus 5y plus 2x squared. Now we can enter the answers over here on this system. When you're entering them, you can do the power either using the palette window or you can use the caret symbol. Let me show you what that looks like. So over here, we have the answer 4x, open parentheses, it understands automatic multiplication, negative 3 minus 5y, if I can see my numbers, 5y plus 2x squared plus 2x. And now to do a square, you can hit the caret symbol, which is above the 6, and then you can put a 2 after it. It takes the caret and raises that base to that power. Now what we can do is we can come down here and we can tell it to check our answer. When we check our answer, it will go through and it will tell me if I've done something incorrect. Notice that I left off the closing parentheses and it made note of that. So I'm going to come up here, I'll put in the closing parentheses, and then I'll tell it to check the answer again. What I'm looking for, is a green check. Something has gone awry. Notice here that it is entering it the way that I wanted it to look. Now, what is wrong? Let's read the directions and see if I've done something incorrect. So I'm doing lots of things wrong on purpose so that you can see what happens and how to fix it when things go wrong on your homework. When you're looking at the directions, it says find the greatest common factor among the terms in the polynomial expression. The greatest common factor is, of course, I factored it instead of just giving the greatest common factor. So what it wants, although it interpreted what I put down correctly, notice that it types it up here with the square on x. It only wanted the greatest common factor, which was 4x. So erase the back part in the parentheses and check your answer again. This time we get the green check, so we know we've done it correct. Let's move on now and take a look at the next problem. Let's move on to problem 2. In the next problem, it says find the greatest common factor among the terms in the following polynomial expression. The coefficient of the GCF must be positive. So again, we're looking for the greatest common factor of these terms that we see right here. Let's come over here and let me show you how I'd like you to write up your homework. First, I would like you to go ahead and label each problem. I like to number them and circle them so I can find it. Then you want to write down what the answer is. The GCF equals 4x. Circle that too so you know what it is. Then draw a long horizontal bar to separate this problem from the next problem. This is super important on tests because it gets very difficult for me to find out where one problem starts and one problem ends. So the horizontal bar really helps me to do this. That also means that I absolutely hate double columning. Do not double column your work, please. Paper is relatively cheap. It only costs about a penny or two a page. Go ahead and use the full width of the page for each problem, and then draw a horizontal line that goes all the way across the page. No double columning. Now let's work on number 2. For number 2, I have 24xy cubed plus 42xy squared plus 5x to the 5th, y to the 4th. And I want to find the greatest common factor. We're going to start with numbers 24, 42, and 5. I thought I was on a roll with 24 and 42 since they're both divisible by 6, but the 5 kind of put the kibosh on that. 5 is a prime number. If 5 doesn't go into these numbers, then they don't have a greatest common factor that is just a number. So now we look at the variables. I like to go in alphabetical order. 1x, 1x, 5x's. The least I have in any one term is the most I can take out. Since the first 2 terms only have 1x, my greatest common factor is only going to have 1x in it. What about the y's? The first has 3, the second has 2, and the fourth one has 4. Again, the smallest number in any one term is the most that can come out. Because the second term only has 2 y's, I can only take 2 y's out. And that gives me xy squared. Let's try an experiment this time when we enter in our answer. And let's see if the palette symbol works. I have never used the palette symbol. I confess, I always do the caret, but this will be something interesting. X, Y, where's my Y? Okay, hit the palette, come over here and look at what it's got. Looks like I don't need any of those. I need exponents. So now hit the exponent button. Oh, so what is the exponent button does is it inserts the caret for me. Well, if that's all it does, I'm probably going to keep typing the caret myself. Now we want to put in a 2, and then we'll check our answer. We hope we get the green check. Heck, it didn't like it. Did I copy the problem wrong? Let's take a look at the problem. I did copy the problem wrong. That's one of the first things you want to check. It's very hard to find your own mistake. So I encourage you to work together because someone else can find your mistake so much quicker than you can. It doesn't mean you're doing anything wrong. It just means that your eyes see what your brain expects to see and not what's actually there. So let's look and see how to figure that out. One thing you can do is go character by character. 2, 4. Do I have a 2, 4? Yes. X, Y cubed. X, Y cubed. Yes. 4, 2. Yes. X, Y squared. Yes. 50. Uh-oh. I put 5, not 54. And I've got X to the 5th, Y to the 4th. Now that this is a 54, I can definitely take out a 2 from all three, but that's not the largest. The largest I can take out is probably 6. This becomes 6 times 7, and 7 doesn't come out of 24 or 54, but 6 does come out of 24, 42, and 54. So 6xy squared would be my greatest common factor. Let's fix that problem now. Put the 6 in, and then check our answer. Ah, that lovely green. It's so satisfying. Okay, let's move on to problem number 3. We'll see how many more different mistakes I can create so that you can learn how to troubleshoot your own work. Factor the following polynomial expression. This is asking me to do what I was trying to do in the first problem, which is fully factor it. So when I'm looking at this one right here, notice that this is a trinomial, x squared plus 9x plus 18. I want to factor that into the product of 2 binomials if I can. So I'm going to come down here, draw my horizontal bar all the way across the page, circle my answer. Then I'm going to write the problem. X squared plus 9x plus 18. Please, please write the problem down, unless it's a word problem and there's a lot of words. The reason is sometimes your brain sees something different, like mine did on the last problem. It saw 5, not 54. If I can see the problem you're starting with, and you've got an error in that first line, then I know the work isn't going to match the answer. But I can look to see if you do the steps from that point correctly, and then I can give you credit for that. But I can't give you credit if you don't write down the problem. I need to know what you're starting with. That's to protect you, not just to make you write more. Okay, looking at this, there are different ways of solving a factoring of a trinomial. Trinomial means there are 3 terms. Now, one method is called trial and error. And it basically goes like this. X squared is going to split up as x and x. So you have an x there and an x there. When this sign is positive in front of the constant, then the signs are the same. It doesn't mean they're both positive. It means they're the same. So this right here tells me I've got the same sign. Then the middle sign tells me they're both plus. And then I think about all the numbers that multiply to give me 18, but would add up to give me 9. Now, the numbers that multiply to give me 18 are 1 and 18, 2 and 9, and 6 and 3. But the only ones that add up to 9 are 6 and 3. So I can put 6 and 3 in whichever order. It won't matter because they're both plus. And that's how you do the sort of trial and error method. Now, if you don't like the trial and error method, there's another method called the AC method. The AC method always works. It never fails, and it will also factor the difference of two squares pattern. Now, when we're talking about the AC method, we have to talk at least a little bit about what a quadratic equation looks like. We have ax squared plus bx plus c, where the coefficient of the x squared term is a, the coefficient of the x term is b, and the constant by itself, even if it's 0, is c. Now, how does the AC method work? When you look at the AC method, it's based on factoring by grouping. So when we talk about it, we need to know how to factor by grouping. That's going to create 4 different terms, right? The first thing we want to do is form what is called AC, which is the multiplication of the coefficient of x squared by the constant. So AC in our problem, if we scroll up, there's an understood 1 here times 18. So AC equals 18. Now, what do we need to do? We look at the last sign, which is a plus, and we know that that means the signs are the same. If the signs are the same, we're looking for a sum. Sum means add. Since we're looking for a sum, we come down here and we write the factors of 18. 1 times 18, 2 times 9, and 3 times 6. And we look for the pair that has a sum of the middle term. Our middle term is 9x. So we look for that. Because they add up to 9x, then we can rewrite our original problem, x squared plus 9x plus 18. And we can split the 9x into 2 pieces. We write it as x squared plus 6x plus 3x. So this becomes split into 2 pieces, plus 18. The AC method is longer than the trial and error method, but on difficult ones, it can be shorter because it's a definite process. And when you get to the end of the process, you have it correct. Now, how did I know these were all the factors? I start with 1, then 2, then 3. 4 doesn't go into 18. 5 doesn't go into 18. 6 does, but I've already got 6. That's all of them, all right? Then I look down here and I've grouped these, usually in the order that they're written. I look for the greatest common factor on each one. The greatest common factor on the first pair is x and leaves behind x plus 6 when I factor it out. On the second pair, this plus has to come down here as part of what I'm taking out. The greatest common factor of 3x and 18, when I look for the GCF, is 3, and that leaves behind x plus 6. Now I've reduced it from 3 terms here, and then it went to 4 terms here, separated by the pluses and the minuses if you have them. And now I have 2 terms. Why only 2 terms? The plus signs inside the parentheses don't count. They're hidden or buried inside parentheses. Now what I do is I'm going to look for a common factor here. The whole group x plus 6 is a common factor. So I pull out the x plus 6 and it leaves behind the x plus 3. And now you can see the factored form. AC method does always work, but it can be a little bit more work. But if the trial and error method frustrates you, it's a really good alternative. Let's now take a look at entering our answer. So we're going to enter in x plus 6 times x plus 3. Now we come down, we check our answer, and we have the green check. Moving on, we go to problem number 4. Now we can see that we have x squared minus 64. and we want to factor that. Here was our factored form answer for the previous problem. And now we're moving on down here into problem number 4. If you move to a new page, you don't have to put the horizontal bar. There are 2 methods of factoring the next expression, x squared minus 64. The first is by memorizing the pattern. When you have a perfect square and another perfect square and a minus sign in the middle, and yes, it has to be a minus, cannot be a plus. If it's a minus, then this will follow the pattern a plus b, a minus b, coming from a squared minus b squared. So you take the square root of the first perfect square and the square root of the second perfect square, and you write them inside parentheses, one with a plus and one with a minus. This means the outside and inside products cancel, and that gives us no middle term. That means that this has to be x plus 8, x minus 8. Now, if there were anything else that you could do, like a greatest common factor, you should do that first. And then you can factor what's left. You can also take out the greatest common factor at the end, but it is more difficult. When you're looking at this one, you can also apply the AC method. So let's take a look at what the AC method would look like on the difference of 2 squares. Again, we're looking for ax squared plus bx plus c. A here is 1, b is 0 because I don't have an x term, and the constant is a negative 64. The negative right here tells me I'm looking for a difference, and I have different signs. Since I'm looking for different signs, then I'm going to subtract. That's what difference means. Difference means subtract. 1 positive, 1 negative. Now what do? I form A times C again. So AC is equal to a negative 64. Now I usually don't worry about the signs too much. I go ahead and use logic to help me figure out what the signs have to be. I know that I'm looking for factors of 64 that when I subtract them, I get the number in the middle, which is 0. So now I'm going to list all the factors of 64 to show you a little bit how it's done. 1 and 64, 2 does go into 64 and leaves 32. 3 does not go into 64. You can add the 2 digits of 64 together. 6 plus 4 is 10. 10 is not divisible by 3, so it's not divisible by 3. Now that trick only works for 3, so don't try it on any other number. 4, yes, 4 goes in. 16. Notice that the numbers here are getting closer together. When they meet in the middle, you've got all the factors. 5, no, 5 doesn't go into 64. It doesn't end in a 5 or a 0. 6, no, 6 goes into 60, which is only 4 away. 7, no, 7 goes into 63. 8, yes, 8 times 8. And there it is. You can see they've met in the middle. I have all the factors. And I'm looking for ones that subtract to give me 0. So it's got to be a plus 8x and a minus 8x. So I start with my problem again, x squared minus 64. And I write it with a plus 8x and a minus 8x, which gives me the 0x in the middle, minus 64. Then I group them, first 2, second 2. Out of the first 2, the greatest common factor is x, and it leaves behind x plus 8. To make this work, the other one has to also leave behind a positive x plus 8. In order to have that happen, I need to take out the negative by factoring it. So I factor out a negative 8, which leaves behind x plus 8. If you're not sure, go ahead and redistribute in your head to make sure that it gives you back the original. We've gone from 4 terms here to 2 terms here. The x plus 8 in parentheses factors are identical, So now we can take out the x plus 8, and that leaves behind x minus 8, which is our factored form. I'm not going to put the answer in this time. I'm simply going to leave it, and we're going to go on to problem number 5. On your homework, of course, you need to put the answer in. Let's look at number 5 now. Number 5 says factor the given polynomial. If the expression cannot be factored, then answer with prime. Aha, they mentioned that it could be prime. So this is something we should be suspicious of. Let's come down here, create our horizontal bar, and start with number 5. We have y squared minus 6y minus 27. The method of trial and error is going to look at the y squared and say y squared splits up as y and y. This sign is a minus, which means that we have different signs and that they subtract. That gives us a difference. Now, I leave the signs out until I'm done to make sure that the sign in the middle is correct. I need two things that multiply to give me 27, but when I subtract them right here, I get 6. Well, what multiplies to give me 27? 1 and 27, 3 and 9. Well, it's not 1 and 27, that subtracts to give me 26, but 9 minus 3 is 6. So I think one of these is a 9 and the other one is a 3. Now, because this is a negative, the signs are different. So since I have different signs, one of these has a plus and one has a minus, but I've got to figure out which one. The larger product is 9y. The smaller product is 3y. The larger one will pull it to whatever sign is in the middle. In this case, the minus. So it's minus 9 plus 3. Again, we can do the AC method. The AC method would give you negative 27. Then you would write the factors of 27, 3 and 9. You would know that they are different signs, so you need to subtract. One's got to be positive, one's got to be negative, but they have to combine to give you negative 6y. That will give you y squared minus 9y plus 3y. This, of course, replaces the minus 6y minus 27. Then you group each pair together and take out the common factor. This would give me y times y minus 9. Here I've got a positive, then a negative, and this is positive, then negative, so the signs look okay. So I'm going to take out just a positive 3, and that gives me y minus 9. And then when I take out the y minus 9, I get y plus 3. I hope this is making sense on the AC method. I do have a handout on it that you can find in course resources on D2L. Let's move on to problem number 6. Looking at number 6, we have 9x squared minus 225. This does not have a middle term. Is 9 a perfect square? Yes. Is x squared a perfect square? Yes. Is 225 a perfect square? You may not know. Well, it ends in a 5. So it's got to be something that ends in a 5 itself. And it's not 5 because 5 times 5 is 25. What about 15? Try 15. Yeah, 15 squared is 225. So we can think of this as 3x being squared minus 15 being squared. The pattern becomes a plus b, a minus b. This is the one that you memorize. If we're going to do this one, then this would give us in the factored form 3x plus 15 and 3x minus 15. Uh-oh, I did something I shouldn't have done. What did I do? It wasn't obvious in the 9x squared minus 225 form, but 9 is a factor of 225. I should have taken out the greatest common factor first. Can I take it out now? Yes, but it's more difficult. I'll show you how to do it, then I'll redo it the proper way. Notice that 3x plus 15 has a common 3. I can take the 3 out of that, leaving behind x plus 5. The 3x minus 15 also has a common 3. It scoots to the middle at first, but because these are multiplied together, I have what's called the commutative and associative property, so I can reorder them. That will put the 3 at the front with the other 3 and give me a 9 times x plus 5, x minus 5. Now, if I had been paying attention, the first thing I should have done is factor out the 9 from the x squared minus 225. 225 divided by 9, well, you may want to grab your calculator and see what it is, but it turned out to be 25. Then you go ahead and factor this. The most factored form is the one where you can't do anything else to any single factor. This is the difference of two squares, so it becomes x plus 5, x minus 5. Can you use the AC method on this one? Yes, you can. It would be 9 times 225, and it would be negative. And I'm going to have to do that one on the calculator because that's not a number I know. On the AC method, you would end up with the product 2025, which is whoppingly large, which means that this is not the greatest method on this one because you'd have to go through all the factors of 2025, which is 1 and 2025. Is it divisible by 2? No, it ends in an odd number. 3? Well, 2 plus 2 is 4, and 4 plus 5 is 9, and 9 is divisible by 3. So when we divide by 3, we get 675. How about 4? There is also a rule for 4. 4 is if the last two digits are divisible by 4, then it's divisible by 4. The last two digits are 25, but 25 is not divisible by 4. 5, definitely, it ends in a 5. So when we divide by 5, we get 405. What about 6? Well, I don't know. I just have to try it. No, it gives me a fraction. So not 6. How about 7? Try it out. No? Okay. How about 8? Well, it can't be 8. 8's an even number and it's not divisible by 2. How about 9? Yes, it's divisible by 9. And if we take 2025 and we divide by 9, we get 225. There are more factors that are involved, and you can keep going from there. You're looking for the pair that gives you 0 in the middle. So you're going to have to keep going until you find it. Another way of doing it is to take each of the possibilities that you have and break them into their prime factors, and then start rearranging them. You know that you've got a 15 and a 15 and 225, which means that you've got another 3 times 5 and another 3 times 5, which means that we can definitely form, for example, a 27 or a 25 or an 81 or any of those numbers, 15, whatever is possible out of these prime factors. This, however, is not the best method for doing this problem. It would take a long time to find it, but it does exist. It is out there, and it is probably 45 and 45 would be my guess. Let's give it a try and see if that works. 2025 divided by 45 is 45. Now, how did I get the 45 and the 45, and why? I knew I was looking for something that added up to 0, and I saw that I had 1, 2, 3, 4 threes. So I cut them in half and I put 2 of them here and 2 of them here. I had 2 5s, so I put 1 5 here and 1 5 there. And that gave me 45 times 45. Let's move on to problem 7. In problem 7, we have another trinomial, x squared plus 16x plus 63. Which method are you going to use? Go ahead and pause the video and either use the trial and error method or the AC method. Then turn the video back on and compare your answer to mine. When you're looking at this problem, notice that the last sign is a positive, indicating that they're both going to be the same, and the middle sign is a plus, therefore they're both plus. That means we're going to add. If you're looking for two factors of 63 that add up to be 16, you get 7 and 9. With the AC method, you get 63 times 1, or 63, 1 and 63, 3 and 21, and 7 and 9. But only 7 and 9 add to give you 16. Then you replace the 16 with 7x and 9x, group them in pairs, factor out the greatest common factor, and then pull out the binomial common factor from the second line. Now let's move on to the next problem. Our next problem is problem number 8. In problem number 8, we've got 4t squared plus 19t plus 12. So 4t squared plus 19t plus 12. I'm going to remember this time to look for greatest common factor first. It's easier at the beginning. If I did that, I've got a 4 here, but 19 here, and 19's prime. So no common number. What about t's? I've got t squared and t, but no t's here. I have no common factor. This one is different because my a is no longer 1, it's a 4. So what I'm going to do now in the trial and error method is I have to figure out how to split up the 4t squared. It could be 2t and 2t, or it could be 4t and 1t. What about the 12 at the back? This is a plus. That tells me that they have the same sign. And this is a plus, which tells me they're both going to be plus signs. I could go ahead and put that much in. That I know won't change. That tells me that I need to add the outside product and the inside product. But this is a lot to split up. The 12 can be split in 3 different ways. 1 times 12, 2 times 6, and 3 times 4. So I could pair the 2 and 2 with all of these 3, or the 4 and 1 with all of these 3, and that's 6 possibilities. Let's try the AC method and see if it's faster. For the AC method, I get 48 for A times C, coefficient of t squared times the constant. Then I form all the factors of 48, which is 1 and 48. It is even, so 2 and 24. 4 plus 8 is 12, which is divisible by 3. So 3 goes into 4 once, with 1 left over. 3 into 18, 6. 4, yes, 4 goes into 48, leaves me 12. 5, no, it doesn't, into 5 and 0. 6, yes, 6 times 8. The only thing between 6 and 8 is 7, and 7 doesn't go in. Now look for the pair that adds to give you 19. Not those, they add up to 14, that's 16. 19, there it is. Now let's rewrite what we have at the beginning, 4t squared, and replace the 19t with what we have here on the right. So we have a plus 3t plus 16t plus 12. Now we group them 2 and 2. Now we take out the greatest common factor from each pair. T from the first, because the constants don't have any common factors. That leaves 4t plus 3 behind. The second one needs to also be 4t plus 3, or the method failed and we chose the wrong pair over here on the right. 16 and 12 have a common factor of 4. I'm going to take out the positive 4, note the plus is part of it, and that will leave behind 16 divided by 4, or 4t. That checks with what that one is. 12 divided by 4 is a 3, which checks with what that term is. And then I've got the 4t plus 3, which is common. So I take out 4t plus 3, which leaves behind t plus 4. What about problem number 9? Looking at problem number 9, we see that we again have something with a coefficient of a being other than 1. We're going to try this one again using the AC method. When we're looking at this one, we have 5a squared plus 7ab plus 2b squared. This last sign is positive, which tells me they have the same signs. The middle sign is positive, which tells me they're both plus. That tells me I'm going to add the outside and inside product to get the middle term. This time, though, I've got a b squared at the back, which is a little unusual. How is this going to split apart? Well, we're going to get a number times a and a number times a, and then we have a plus and something times b and something times b. But we don't know what numbers are going to go where the question marks are. But we know they'll split up in that pattern. Now let's take a look at the numbers and see if we can figure out how to split them up. 5 and 2 are prime, so they can only be 5 and 1 and 2 and 1, which gives us fewer options, but we can always pair the 5 with the 2 and the 1s together, or the 5 with the 1 and the 2 with the 1. So there are options still. On the AC method, if we look at this, we have 10. The factors of 10 are 1 and 10 and 2 and 5. The pair that adds up to 7 is 2 and 5. So we have 5a squared plus 2ab plus 5ab plus 2b squared. Pair them up, take out the greatest common factor. This time the greatest common factor here is a, which leaves 5a plus 2b. On the second pair, only the b is common and it's positive, so I factor it out and I get 5a plus 2b again. That makes 5a plus 2b a common factor. 5a plus 2b times a plus b. The order of the binomials does not matter because multiplication is commutative, so you can commute or switch the order. Let's look at problem number 10. Problem number 10, we also have our a being other than 1. That makes those problems more difficult. We have 25 y to the 9th plus 10 y to the 8th plus y to the 7th. Now, don't forget, greatest common factor comes out first. So I've got a 25 and a 10, which are divisible by 5, but only the constant 1 on the last one. So no number coefficient comes out. 9 y's here, 8 here, and 7 here. The smallest number I have in any one term is 7, which is this one. I'm going to take all 7 y's out. In division, remember that when you divide y to the 9th by y to the 7th, you subtract the exponents. 9 minus 7 will leave behind 2. You can also think of it as having 9 to start with and taking away 7 of them. And when you take away 7, you only have 2 left. From the middle term, the 10 is still there. We took 7 of the 8 away, so we still have 1. The last one, we took all 7 out, but to get it to come back to where it started, we need the placeholder of 1. Now we have to look at this trinomial and see if it will factor more. If it doesn't factor more, it's prime. So then we can look at this one, and because we have an a other than 1, I like to use the AC method. So if I form AC, I get 25. That's 1 and 25, and well, just 5 and 5. I know from this that they're the same sign, and I know from the middle term that they're both plus. And that tells me that I'm going to add. I need 2 that add up to 10. So it's got to be 5 and 5. The y to the 7th doesn't disappear. It simply follows along. So we have y to the 7th times 25y squared plus 5y plus 5y plus 1. You may want to make your curved brackets into square brackets to differentiate. When you pair them up and take out the common factor, the first one has a common factor of 5 and y. That's going to give me a 5y outside parentheses, leaving behind a 5y plus a placeholder of 1. My second one, I don't have a common factor. So what do? Well, I just leave the common factor as 1 and I put it inside parentheses. Notice that the binomials are now identical, 5y plus 1. So I can now take out the 5y plus 1 as a binomial factor. What does that leave behind? This is a little tricky. There is a number here. It's understood to be there, but it's not written. Can you write it? Yes, absolutely. If you want to, put a 1 there. What gets left behind is 5y plus 1. This is actually a known pattern. It's a perfect square trinomial or a perfect binomial square. That means the binomial is the same. So you can either write it in that expanded form, or because it's the same binomial, you can write it as 5y plus 1 quantity squared. I would take either of these two answers on an exam. Be sure when you're writing up your homework that you do follow these guidelines. Let's now take a look at problem number 11, which is the last problem. How do I know? Well, because there is no next problem. It got grayed out. It says to factor 2x squared plus 3x plus 1 first. Well, since my a is not a 1, I could factor using the AC method. If I do the AC method, I get 2. 2's prime. There's only one pair, which is 1 and 2. Does it add to 3? Yes. The signs are the same. This tells me they're both plus. I haven't had any that were both minus, have I? And this tells me I'm going to add. So I would write it as 2x squared plus x plus 2x plus 1, factoring by grouping. You can also use the trial and error method. This would give me x times 2x plus placeholder 1 plus, well, the second one doesn't have a common factor. So take out a 1 and leave it as 2x plus 1. Then the 2x plus 1 is common, and that leaves behind an x plus 1. What about part B? Part B says use your previous answer to factor this more complicated expression. In the more complicated expression, it has 2 times y plus 2 quantity squared plus 3 times y plus 2 plus 1. How does that compare to the original problem? Well, if I'm looking at the original and I replaced the x with y plus 2, they would be the same. So it's almost like a pattern. 2 times something, we'll call it a happy face, squared, plus 3 times a happy face, plus 1. How does it factor? Well, 2 times the happy face plus 1 times the happy face plus 1. In other words, it is a pattern and there is a placeholder. Now we're going to replace this happy face with y plus 2, the next placeholder. So this would factor using the pattern that I see here. I would have 2, open parentheses, y plus 2, close parentheses, plus 1. This goes in my first set of parentheses, which I'm going to make square to differentiate. In my second set of parentheses, which I'll also make square, I start with the placeholder, which is y plus 2. And then I have a plus 1. And then I can close it. Now, what could I do in order to simplify this? WebWork will probably take this answer if you type it in. But I could simplify it by distributing the 2 over the parentheses, y plus 2. That would give me inside square brackets 2y plus 4 with the plus 1 tagging along from here. In the second, I can combine the 2 plus 1 and I can get y plus 3. Finally, I can combine the 4 and the 1 to get 5, and I can write 2y plus 5 times y plus 3. Now, I don't know how WebWork feels about square brackets, so you might be better off using round ones when you type it in. That's all for the homework out of 1.5. I hope this helped and was a good review for you on how to factor.